Hello grade 12s, welcome to yet another video, and today let us spend some quality time with this babe. She's a little curvy and a bit of feisty one actually to deal with, but let us have a look through and map our way around it. I hope those who are writing next month, they are upgrades, or should we say they are finals, so this may give you a bit of an idea of what to perhaps expect and some of the things that you need to work around similar problems. Okay, so this was taken from KZN during the March exams or Term 1 exams for 2023. So let's look at the instructions. Always make a habit of ensuring that you are clear on the instructions. Of course, the first one gives you a topography of the paper and you are instructed to answer all questions, but what makes more of an operative rule is to say show clearly all calculations, diagrams, and absolutely anything that is acceptable in maths that you have used in determining your answers. All right, and then of course this one comes into yet an important consideration. Don't know why it chose to become a heart. Anyway, doesn't matter. So here we are to round off to 2 decimal places. So basically no less, no more. Okay. So we're instructed that we restrict our rounding off to just 2 decimal places. And then of course the rest is as you know it. Okay. Let's just get to question 1 and start working through it. It says now consider the quadratic sequence. So once you are given exactly what is the sequence you're working with, it becomes a lot easier because you know there is a constant second difference here. And of course the sequence of the first differences makes up an arithmetic sequence as a result. All right, so we are moving from 2 to 7 to 14 to 23. It says now write down the 5th term. So this is term 1. This is term 2, term 3, term 4. So we're looking for term 5 here, which is the next one. Okay, great. So how do we start attacking a question like this? Well, we take down our sequence. All right, so we've got this situation here, and we know that the difference between the first 2 terms gives us a 5, okay, which makes the first term of the first differences. Now again, the difference between the third and the second term gives us just a 7. The difference between the fourth and the third gives us 9, okay. Then again, we move on and say what's the difference between the first 2 terms of the first differences is a 2. The difference between the third and the second term of the first differences gives us also a 2. All right, so what works usually if you want the next term? If you take these, I don't know why the things refuse to do the things. Okay, so if you're looking at those 3, if you add them up, they actually give us the next term. So 2 plus 9 plus 23 gives us 34. Okay, that is actually the next term. All right, so to answer that question now of 1.1, what do we know? We know that T5 is equal to 34. That's it. You get 1 mark. Okay, no problem. Next one, it says determine the general term, Tn. So once we want the general term Tn, it means we're going to have to find the nth term. Okay, so we've developed some nice techniques that you first focus on the constant second difference, and then you can put your attention to the first term of the first differences, and you can actually place another piece of attention to the very first term of the quadratic sequence. Okay, we know that the constant second difference is in general given by the expression 2a. Okay, and then the very first term of the first differences is given by that expression 3a plus b, and the very first term of the quadratic is actually a plus b plus c. Okay, where does all of this come from? It comes from the general term of a quadratic sequence that is expressed as an squared plus bn plus c. So all of this came from this general quadratic expression. Okay, so not a big deal. But again, I would warn you, do not limit yourself to just looking at the very first terms of each of these sequences that make up that quadratic entirely. At times you may want to look at the second term of the quadratic, okay, and you may look at the second term of you may want to look at the second term of the first differences, and then of course the constant second difference is always the same, so it doesn't matter where you look at it. Okay, so maybe we may find some time to demonstrate that. Let's just start working. So from the expression above we can tell that, okay, to answer 1.2, we know that 2a is equal to 2. Okay, so when you divide by 2 throughout, we get 1. So a is actually 1. So we start from the bottom, as in you always start from the ground up, isn't it? Yes. So this implies what? That 3, now instead of a we're going to put 1 plus b, should be giving us the very first term of our first differences, which is a 5. Now when we solve algebraically, what do we get? It's going to be 5 minus 3, which gives us a 2. Okay, and then this also implies that in this case a is 1, b is 2, plus c should be giving us the very first term of the quadratic, which is a 2. Okay, therefore our c becomes, now this becomes a 3. When you transpose it, it becomes a minus 3. So 2 minus 3 is minus 1. Okay, so that in a way gives us the conclusion that our nth term should be equal to n squared plus 2n minus 1. Okay, that's the answer that was being looked for, and we found it. Now we need to test it, because if you don't check, you may run into a problem. Sometimes mistakes do occur here. A bit of a sign situation can mess it up. So let's look at it. If we put, for example, the second term, say 2 squared plus 2 into 2 minus 1, it gives us 7. And do you see that the second term was a 7? So let's check another non-contiguous term. Say, for example, we're going to take t4. Okay, so inside our brackets now we're going to put a 4, and what we're getting is a 23. So if this checks out like that, then we know we have done it. So you always get a mark for getting these little coefficients, okay, and constants. So we know that the formula that we got actually is representative of our sequence. Now let's move on. What's the next question? It says if 5, okay, if 5 is added to each term of the quadratic sequence, between which two terms of the sequence is the first difference equal to 57? Okay, between which two terms of the quadratic sequence will the first difference be 57? Okay, so that's easy. We know that, well, if we're adding 5 to each of these terms of the quadratic sequence, when we're taking the first differences, it won't matter. So this is just a dummy. They're just putting it as a dummy to mess with your head, because it doesn't change the sequence of the first differences, because the 5s that we added essentially eliminate each other, such that the very first term of the first differences is a 5 going to 7, going to 9, and so forth. So that sequence of the first differences does not change, even though we've somewhat changed the original quadratic sequence. Now, to answer this question, we know that, well, this one is an arithmetic sequence, therefore, so we know that Tn, as given by the statement, is 57, okay? So what do we know? We know that Tn is expressed as a plus n minus 1 times d equals 57. So what do we do now? This implies the first term was a 5 plus n minus 1, because we're looking for n, but the common difference there was a 2, isn't it? Yes, equals 57. And then we sort it out nicely. This is 5 plus 2n minus 2 equals 57. And we can make our nice conclusion, because I can see, okay, we still have a bit of time. We can just work it out nicely. We know that 2n is going to be equal to, we transpose this, by the way, 5 minus 2 is a 3. We transpose that, it gives us a 54. Therefore, n is going to be 54 by 2, which is 27. But remember, what is this n here? If we're looking, for example, if we're looking at T2 of the first differences, you know, maybe let's make it different. So if we're looking at T2 of the first differences, do you see that T2 is between T3 and T2? So this number always coincides with the term that is lower of the two that made it up. Just a moment. Okay guys, that was just a phone call, so let's just carry on. So as we can see that, look, this term number in the first differences always coincides with the lower term of the two in the quadratic sequence that made it up. Okay, so let's see, if we're getting n as 54, it means that 57 is their difference, okay, between T, now remember it's going to be one ahead, which is going to be T28 and T27, okay, because we know that the nth term, or the term number in the first sequences, in the first differences, always coincides with the lower of the two terms in the quadratic that made it up. Okay, easy. So how many marks were we getting here? We were getting 3 marks. Okay, great. So usually correct substitution into some correct formula is usually correct, and then finding that 27 was important in the final statement should, because it includes a guy that we need to know about. Okay, great, let's move on. Next question says 10 going to A, going to 24, going to B, going to 38 are the first 5 terms of an arithmetic progression. So what do we know about an arithmetic progression? It is a progression between two consecutive terms that such that we get a difference that is common or is constant. Okay, now it says show that A is 17, B is 31. That's easy. So we're going to answer what is this? What is this? So 2.1.1. We know that if we take a, for example, minus 10, for example, that should be the same as when we take 24 and subtract a, isn't it? Yeah, that is the story. And the reason is because each difference is equal to the common difference, d. Okay, so at times you don't want to say a complicated thing. That's it. That's that. In an arithmetic sequence, we have a common difference or a constant difference between each two consecutive terms or any two consecutive terms. Anyway, so we move on. Say this implies we transpose a to the other side, we get 2a equals, we transpose 10, we get 34. All right, therefore a, why is my a decreasing in size? A is going to be equal to 34 by 2 is 17, right? And that's exactly the answer we were looking for. We can say also, we can almost tell that if we do the same smart thing and say b minus 24, it should be equal to 38 minus b, right? Yes. And what is the story here? We can say each difference is equal to the common difference. I like this set type of brackets. Anyway, this implies when we transpose b, we get 2b equals 38 plus 24. That should be 62, right? Just double check. 38 plus 24, yes, it's 62. Therefore, our b, we're going to say 62 divided by 2, it gives us 31. And that is exactly what we were supposed to find. So that's the second mark. So questions like this, they look intense, but you see you only get a mark for an answer. Of course, you cannot just write an answer without showing the workings. Now, next question says, calculate the sum of the first 67 terms of the sequence. Okay, now that's fine. This is 2.1.2. 2.1.2. For me here, I don't need to struggle because I already know my first term. That is a. Okay, that is a now in terms of the sequence, not necessarily this variable. But this variable a here is basically 17. Okay, so 17 is in the place of a, and then we saw that here 31 replaces b. Okay, so if we want the sum, we need the common difference. So we know that d is going to be equal to 17 minus 10. You can pick any of these two so that you get the answer. So this is 7. So we know the common difference is 7. Now we set up the Sn formula. Sn is equal to n over 2 into 2a plus n minus 1 times d. Okay, that's the general Sn formula. When we substitute, it means S67 is going to be equal to 67 over 2 into 2 into 10 plus 67 minus 1 into 7. Okay, then we get an answer that therefore our S67 is equal to whatever value we're going to get there. So let's put it into the calculator and start moving. So I'm getting 16,147. Okay, now in a question like this, you just need to make sure your values are correctly substituted into a correct formula, and you move on, because you can see it's just 2 marks. So there's nothing else you can do to double check or triple check here. You just make sure your substitutions are correct and that the answer follows from those substitutions nicely, okay, or contiguously. There mustn't be jumps around, okay. Now we're told here, if there are 67 terms of this arithmetic sequence, determine the sum of all even terms. Now this part here, even terms, in this sequence. Now, of course, the sequence, we can see it's a sequence of numbers. So which ones are even? We can tell that 10 is even. We can tell 24 is even. We can tell 38 is even. Oh, I don't know what it's doing. 38 is even. So we want the sum of all those terms that are even. But let's investigate what was happening here. This was T1. And then this one was T2. This one was T3. This one was T4. And so on. But do you notice something? The odd terms here. The odd terms T1, T3, T5 are actually even in terms of their actual value, isn't it? So this means the odd number in terms of the general position of that term is actually even, because you can see 1 is odd and it is actually 10, which is an even number. The third one, which is odd, is actually an even number, 24. The odd one, which is 5, is actually 38. So these are some of the questions that you may think are easy, but they are not. Okay, these are the questions that demand a lot of understanding from a student. So it's fine, let's do it. So this is 2.1.3. Do we have space? It looks like we do. Okay, so now for this question to be answered, what do we need to do the sum? We need the number of terms. Okay, so we need n, but now we need to also realize what would be the last term. Now, since we can see that when we investigate our sequence, every odd term, when I say odd term, I mean term number, as in T1, T2, T3, every odd term number is actually an even number in terms of its value. So we can already tell that, look, T67 is an odd number, so it should be an even number, looking at this pattern right here. So we can tell that, all right, okay, we want the last term here, because the last term will give us what? Yeah, let's say the last term here, the last term, I don't know how we're going to write it. Let's just say L is going to be T67, okay, which is equal to, now we know that the nth term here is found by saying A, so writing a formula doesn't help anymore. It's going to be 10 plus, remember we're talking about the general. This L is all about the general term. It's not, we're not talking about this sequence of even numbers. We're just talking about the last term of the original sequence. Make sure there's no mistake there. So this is 10 into 67 minus 1, and the common difference that we got was 7. So we just want the last term at the moment, because that's what is important. So 10 plus 67 minus 1 into 7, I'm getting 472. Okay, so that means our sequence is going to be something like this. Okay, now we also need to know n. Okay, now if this is our last term in the sequence that we are now forming, and you can see T67 is an even number, it's a multiple of 2. or it can be divided by 2. So it is an even number, and that should be the last term because we only have 67 terms in the original sequence given. Now we want to work out the number of terms, meaning now in the new sequence. So we can say now this implies that the even sequence, or you can say the sequence of even terms, the sequence of even terms, okay, is given by 10, 24, 38, dash 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 to the last term, which is 472. Okay, so this sequence is going to go on like that. Let me just double check I'm not writing my own things. Yes, so we have a situation where now we need the common difference. So here we can say this means that D in here is going to be essentially, okay, let's double check because we don't know what sequence this is. I'm going to say 24 minus 10, that's 14, right? So let's see, when we say 38 minus 24, it's still 14. So that means it's constant. So we can just say D is 14. Okay, D is naturally the difference between any two consecutive terms. Then this implies that S67, look, you don't need to be writing formulae from the beginning here. So we know that we've got, oh yeah, we need something else. We just don't need only D. We need N as well. Now we know that T67, sorry, we need to know what is this term because we can see it's an arithmetic. So now we need to know its position, the last term. So now we know that Tn is A is 10 plus N minus 1 because we want that, and then the difference is 14 is equal to 472. All right, again, I am only jumping straight into the formula. We're already doing grade 12, so this should not be a problem. So this implies that we've got 10 plus 14n minus 14 equals 472. Therefore, I'm just going to run into the end here. N is equal to, you should know what to do here now. So you've got here 472 plus 4 is going to be 476. 476 divided by 14 is 34. So we can see that we've got 34 terms in this particular sequence. Okay, so that is what we needed. So let's create a bit of some working space now because I kind of gave myself a small space to work on. It means S34. Again, I'm not going to be writing the formula. It's a waste of time at this point. You can see here there's just too many calculations for no marks at all. So I'm just going to jump in and say it's going to be 34 over 2 into, I know the first term, which is 10. I also know the last term, which is 472. So when you know the first and the last term, you just simply put them in there, nice and easy. So let's do it. So 34 by 2 into 10 plus 472. It gives us 8,194. Okay. So that is it. That is it. So, I'm sorry. This is how you work out these kinds of problems. Okay. You work them out in this manner. Anyway, guys, I hope you were able to understand. So you can see this question was complicated, even though it looked simple. So what did we need? we definitely did need the last term of the sequence of the even terms, okay? 2, what else did we need? We definitely did need the number of terms in that particular sequence. And we needed the answer. So you can see here the formulae were not really playing an important position. Of course, don't be like me. Write out nice formulae and substitute. But when you're confident, you actually can just write a substitution straight away. No one is going to hurt you. They know where you got that from. At least that one is easy to understand. If anyone wants to take you down, bring them to me. I will deal with them. Alright? Because some people can be crazy anyway. And just be stupid at times. Anyway, let's go on. Not be silly. It says now, calculate the value of sigma of 3 times 2 to exponent 1 minus r, starting from r equal to 2 to r being infinity or infinite. Alright? So, we can already see here, once we've got a 3 multiplied by a2 to some particular exponent, this is already telling us we're dealing with a geometric series because of sigma. So we're adding each term in that sequence. Okay, but now if we have this going to infinity, it means this is a sum to infinity. Okay. But then when we look onto the next sigma, so we're adding sigma of 3 times 2 to exponent 1 minus r, which is the same general term. So it means this is the same sequence, so to speak, but we're making this one finite by ending at 12. So we decided to end at 12 for this one. So we make it finite. Alright. And then again, it's starting from r equal to 2. So it's starting the same way for the same general formula. So it means the very first term of each one of these two sequences or series is the same. So we can use either one of the two to get the first term, the second term, the third term. Because if we don't expand any one of these two, we won't be able to find out the value of r. And we will need the common ratio here to be able to do a proper evaluation. So let's go on. What do we know here? We know that this sigma, starting from 2 of 3 times 2 to exponent 1 minus r, ending up in infinity. So it is such that we've got, when we put a 2 in there, it becomes 1 minus 2, it's become 2 to the minus 1. So 2 to exponent minus 1 is the same as 1 over 2, or just half. So 3 times a half is going to be 3 over 2. Okay? Plus, then the next one, you put a 3 in there, then it becomes 2 to the minus 2. Then 2 to the minus 2 is the same as a quarter, which is 1 over 4, right? So 3 times 1 over 4 is basically 3 over 4. Then we just need the last one, just 3. Always, when you're given a particular sequence or series in sigma notation, you just need to expand to at least 3 terms so that you can determine whether you have a common ratio or a common difference. But most likely, when there is an exponent somehow, it's going to be most likely a geometric. But do not take chances and overly generalize. You do get surprises. Okay, so let's go on the third one. When we put a 3 in there, a 4 in there, it becomes a 2 to the exponent minus 3. That is as good as 1 over 8. 3 times 1 over 8 is basically 3 over 8. Okay, so that is it. And then plus dash dash, this goes to infinity, so we're not going to worry too much. What we were interested in is this guy, because this is our a value for each term. And now we want r. Okay, let's work out r. So we know that r is going to always be the second term, 3 over 4, divided by the previous, which is the first, which is going to be 3 over 2. And arithmetic will tell you that you're going to flip the second fraction into 2 over 3, and these ones cancel, this one once, twice. So what do we get? We get r is a half, which is definitely a number less than 1, greater than -1, and it makes sense why it goes to infinity. All right, so there's a lot of things that you need to make sure you are clear about. Now we're ready to evaluate. Wow, so much space for this thing. Now we can tell that a is the same for each sequence, right, or series, and the r is the same because we had the same general term and starting the same way. Okay, now we don't want to complicate our lives here, so we can basically see that we're doing sum to infinity here, right? So this boils down to something like sum to infinity, and then we're adding how many terms are going to be here. It's going to be sum of 12 minus 2 plus 1, isn't it? Because always take the top, you subtract the bottom, and you add a 1. So this becomes 11 terms. So this is basically sum to infinity plus sum of the 11 terms, or the first 11 terms of this same series. Okay, so now we can answer the question and say this implies that sum to infinity plus sum of these 11 terms right there, so this is S11, must be equal to, what is sum to infinity is a over 1 minus r, that's the formula, plus S11 is basically going to be a into r. Oh, by the way, our r is less than 1, so we use this formula 1 minus r to the exponent n over 1 minus r. Okay, now we can substitute nicely. So what was a here? It's 3 over 2. Divide by, so we can put it in brackets, 1 minus a half. All right, plus we still have 3 over 2 into 1 minus our r is a half raised to exponent. Now remember, this is S11. This is all divided by 1 minus a half because it's the same. So this is easy, guys, pretty simple. So I'm not going to complicate my life here, just gonna do this nice and easy. So we've got here 3 over 2 divide by 1 minus a half, which is simply just a half. And then we're going to add here plus, again we start here, so we're going to have 3 over 2 into 1 minus a half. Okay, into a half here, this raised to exponent 11. Then we close those brackets. So you see these calculators are perfect. 1 minus a half. I went. They make life a lot easier. So let's see, guys, what do we get? So I'm getting 5.9985 wara wara. But remember, we're told to 2 decimal places. And if we do 2 decimal places, this effectively becomes a 6,00. Right, great. That is the answer of this expression. So again here, there's nothing much you can do. You just make sure your calculations are correct. Make sure your A is correct, make sure your R is correct, and make sure you substitute into a correct formula correctly, and you evaluate properly to the last answer. Otherwise, it can go very wrong. So let's see. Where are these 3 marks then? Of course, this substitution is a mark. that substitution is a mark and the answer. And then of course you had to do a bit of groundwork elsewhere, and you needed to show it as well so that no one, says you copied. Okay guys, let's just carry on. Okay, let's just finish this portion, and then I take a little break and eat something, and then we continue. Now we're told you question 3, x minus 2 all squared plus x minus 2 cubed plus x minus 2 quadrupled, isn't, yeah, plus wara going to wherever it is going, most likely to infinity, forms a geometric series. Okay, not a problem. It says now write down the common ratio. So it says write down, meaning you can work it out on the side and then write it down. So let's do it. 3.1. We've got this thing here. X minus 2, squared, plus x minus 2 cubed, plus x minus 2 quadrupled, plus going on forever. I'm just wasting time because you don't really need to copy it down. So 3.1.2. We want the common ratio. Remember, the common ratio is always going to be the second term, or just the term ahead, not necessarily the second. So this is x minus 2 cubed, I win, divide by the previous term, which is going to be x minus 2 squared. You can even take the third term and divide the second term. It will be fine. Now we can see here that exponential rules come to play because we've got the same basis, different exponents. So this is the same as x minus 2 cubed minus 2. Remember, when this is on the denominator, when you move the exponent to the numerator, you actually subtract exponents. Yeah, so now we've got here x minus 2 basically. So that is the common ratio. You didn't have to show the working, but if you did, it's okay. No one is going to punish you. But I always like to answer questions as stipulated by the instruction itself. When they say write it down, you can show up with this answer. No one is going to ask you, where did you get it? But I'm just showing you how to work it out. You're only getting a mark. Okay. Determine the value or values of x for which the series will converge. Remember, a convergent series, by definition, r has to be less than 1, greater than minus 1. That's the condition for a geometric series to converge. So we'll just start there. If we want this to converge, we equate our r to, we don't equate, but r, we place it between 1 and minus 1. And we solve algebraically. It's a linear equation after all. Linear inequality. So it makes life easy. So 3.1.3. We know that for a convergent geometric series, I'll just say GS, it is such that r is less than 1, greater than minus 1. That is the condition. So this implies that x minus 2 should be less than 1, greater than minus 1, which implies we transpose 2 to this side, it becomes a positive 2. So we're going to have 1 is less than x, less than, now when we transpose this, we get a 3, isn't it? Because it's going to be plus 2 plus 1, we get a 3. Is that the final answer? Yes, because we don't have a specific answer in here. So it says determine the value or values of x. So here we can actually make a conclusion and say therefore x must be less than 3, greater than 1. Easy. Normally you get a mark for this format. Yeah, that is the 2 marks. Of course, you're not going to come up with just the answer. You will be dead you will be dead. But sometimes when they say determine, they usually don't become that strict at times in saying show the calculation. But please do it. Make sure your statements or inferences flow, so that you become the genius that we want you to be, not a hooligan that we rather do not desire. Anyway, Mr. Peter gave his 4 sons. How many are they? 4. 8,400. Okay, the man is rich, to share, such that their shares formed a geometric sequence. So this is applications of geometric sequence. Anyway, I thought I was going to be able to do you guys a lesson on sequences and series. Maybe I'll still do it. I don't know. Time is just a problem. And I get so many ideas. It's so difficult for me to put down a nice and easy to follow lesson, because I always uncover all the corners. At the end of the day, it takes forever. And yes, you will learn if you are patient, but at times it overwhelms me, the very creator. So that's why sometimes I don't really like doing lessons per se. But I can hold a lesson with someone individually. It is much easier, because then I can go to the lengths that they determine. But to throw in a video for the public to consume, it becomes a bit challenging, Anyway, I will see what I can do about it, just to have someone revise before their trials in a way. So let's go on. Now it says the largest share is 27 times the smallest share. Okay, so just given the extremes, the smaller and the largest, that the largest is 27 times that one that is the smallest. Okay, so we can already tell here we're being told information about term 1 and term 2 in a geometric sequence. So we know that we only have 4 terms in this geometric sequence, 3.2. So we've only got 4 terms. So we know that we've got term 1. If we make it x, if we say term 1 is x, remember we're sharing this between 4 sons. This is going to be term 2. This is basically going to be x times r, isn't it? The second term is basically the first term multiplied by the common ratio, which we don't know at this point. The third term is going to be x times r squared, isn't it? Yes. And then the fourth term, we are told it's 27 times the first term, which is going to be 27 x. So we just eliminate r because we don't know anything about r at this point. Okay, it's easy. So it's easy, guys. This is something that we can deal with. Now we're told here, determine the amount each son received, meaning we want the value here, we want the value here, we want the value here, and the value here. Literally saying find the geometric sequence that is formed by these shares of that money. Okay, so that's easy, guys. So we're not going to struggle or stress ourselves. What do we know? We know that definitely T4 is always equal to a r cubed, is it not? Most definitely it is like that. Now the main thing that we're interested in is finding our common ratio, because it makes life easy. And if we can find our common ratio, we will be able to find, do we really need the common ratio? I'm not too sure. But I think we need to find the value of x. But if we don't find the value of r, we will not be able to find these two, because these two have r. So we definitely do need all of those things. How many marks? 4. Yeah, that's a bit. That's a bit. So let's see. This implies that we know that 27 x is going to be equal to a being the first term, which is x. R is what we don't know. Okay, so that's fine. So here we can see the common factor here, or the highest common factor, is x. So if we divide by x throughout and then we rearrange, we can tell that r cubed is going to be equal to 27. Okay, again, exponential rules come in. R cubed equals 27. In terms of a particular cube, it will be 3 cubed. Is it not? Yes. So you're always guided by what you want to eliminate. Here you want to eliminate the exponent. So you want to change 27 to some base raised to exponent 3. Now when you've got a power on either side of the equation or equal sign, such that the bases are different but the exponents are the same, you simply drop the exponent. You drop the bases, or do we say we drop the exponents and we take the bases. So we can tell that therefore r is going to be equal to 3. So we needed this. The space is running out. So we did need this. So what do we mean now? We can tell that now this solves our pain, isn't it? It does. It solves our pain to some extent, but I'm a bit worried. We don't know the value of x. So how do we deal with this? Then it implies, now we go back to T4, because we want x now. How do we solve for x? Yay wena. How do we solve for x backwards? Because this equation is dangerous. I don't know why I'm getting stuck now. I'm thinking anyway of something else. So I'm trying to figure out now, how do we deal with x? How do we deal with x? Because it's nice to find r. Oh yeah, we know the sum. So basically, I forgot that part. So this question is a bit naughty, eh? It's a bit naughty. So we know that the sum of all of these terms gives us 8,400. So we know that, well, S4 is 8,400. So that is the part that was giving me a bit of a nightmare. But now you can see r is a value greater than 1. If r is greater than 1, it means the formula that we use here is the formula where we know that we're going to take a is x, into r, which is 3, to the exponent 4, because we've got 4 terms, minus 1, divide by 1 minus 3 is equal to 8,400. So do you see the only unknown here is essentially x? Okay, let's try and find some working space in this portion here. Slanted. Okay, much better. So we're going to take something here on the denominator and oh man, r is bigger, so you don't put it like that. So it's going to be r minus 1. Okay, so what do we do here? We simply work out this thing, or we just divide throughout by it. So this in turn tells us that x is going to be 8,400 divided by this expression here, which is 3 to the exponent 4 minus 1 itself divided by 3 minus 1. Okay, so we're dividing a fraction by another. I know you can do it in many ways to make your life easy, but I'm not interested at the moment. So let's see. We've got 8,400. We're going to say divide by. Then we sort this one out. So this is 3 to exponent 4 minus 1 divide by 3 minus 1. Okay, so what I'm getting, x is 210. But remember, this is money now, so we're going to put rands. Okay, so we can see that, okay, x is 210. We can say, therefore, the GS, meaning the shares that these sons are going to take, is going to be 210 rands. Then the second son is going to get 210 multiplied by 3. So 210 times 3, it becomes 630 rands. The third one is going to get this one times 3 as well. It becomes 1,890. That's rands. And then the last one is basically 210 times 7. Sorry, times 27. So which is 5,670. Okay. So yeah, that is the story. That is how the sons are going to get the money. Yo, what did I say now? 27 by 210. It's 5,670. And then of course we can add this up and say that plus 1,890 plus 630 plus 210, and see if you're getting 8,400, and it definitely does. So this is the amount each son is going to get. Okay guys, so that question was a bit interesting. Of course, you write the formulae. I am not interested at this point. You guys need to be comfortable with this formulae enough to not waste too much time doing unnecessary things. Okay guys, great. So what was key here was to form a particular sequence to work with, because if we did not have it, life would be a little bit cold. Okay guys, let me eat something and then we'll carry on. Okay guys, let us just continue working. Question 4 says, given the function of x equals 2 over x, that's a hyperbola. Now if you're looking at this value right here, the numerator, that is the a value, which is greater than 0. Okay, so again, this is a hyperbolic function, so you always think of what it would look like on a Cartesian plane. When a is greater than 0, it simply means our graph is in the first quadrant and it's in the third quadrant. Of course, these being the x's and that being the origin. So this means this graph is expected to look like that. And what is also important is that from this information we can tell that f of x is basically 2 over x plus 0 or minus 0. Do we usually use, yeah, we can say minus 0 plus 0, okay, because it already tells us that our asymptotes are right at the origin. They meet at the origin, meaning they are the x and the y axes. So this is stuff that needs to come out as you work through this. And then of course this is a straight line with a positive gradient. So we know that here m, we normally use m for the gradient, is greater than 0. So it means our graph on a Cartesian plane should look something like that. Doesn't really have to be exact. So that is the pieces of information you need to be able to spot, okay, before anyone says anything. All right, so we can tell that we're looking at these two graphs and they look something like that, okay? Not a problem. Not a problem. And in fact, this graph is a bit not correct. Let's not do it like that. So remember, the y-intercept is negative, so it has to do something like so. Yeah, now that's a bit better. That's a bit better. So always approximate your graph to the closest thing to normality. It has to be as close to normality as possible, so that you do not get a sketch that is not representative of what is going on. Okay, that is fine. Now let's move, guys. We don't want to waste time here. We only have 1 hour left now. So it says now determine the coordinates of the points or point where the two graphs intersect, meaning F is equal to G. So when they want the points of intersection, we can call them points of intersections. It's not the point of inflection at this point. Let's say POIs. And what is the story? It means F of X should be equal to G of X. So that's an algebraic calculation, basically. So 4.1. What do we know? We know that here the point of intersections is such that 2 over x is equal to x minus 1. Okay. So basically you can divide all of this, treat it as a fraction, as a unit, and say this is over 1. You just cross multiply here. This implies that 2 is equal to, now when you multiply x in there, it's going to be x squared minus x. Okay, nice. And then we work this out. It's a quadratic, so it's going to be x squared minus x minus 2 when you transpose the 2. I've just rearranged instead. So this can be factorized, most likely, not always. So it's x, factors of 2 that give us a 1. It's just 2 and 1. Now the signs are a terrible one. So this one is negative, this one is positive. Okay. So therefore x is equal to minus 1, or x is a 2. Okay. So means these graphs will intersect there. Hey, I think I'm losing so much space. And then therefore y is going to be equal to, you can just substitute into any one of the two equations. It's going to be 2 over minus 1, or y is equal to here 2 over 2, isn't it? Which is going to be minus 2 here, which is going to be equal to 1. Therefore, our points of intersections are such that minus 1 is to minus 2. Okay. And we know that 2 is to 1. Easy. So we found the points of intersection. Great. So that was a bit of a calculation, and I can already see that I've eaten up a lot of my space. Now it says on the same set of x's, draw the two functions. Indicate the coordinates of the points of intersection of the two graphs. Okay, easy. So this is 4.2. Now 4.2, we know we need a Cartesian plane. Great. And the origin. Now, we know the shape of this graph of f. It is not supposed to be anything better than just this graph right here. Okay, and then what do we know? Now the points of intersection is -1 and -2. So if we say here, for example, we've got -1 here, and then we're going to say here we've got -2 in here, and then if we say this is -1, I mean it's arbitrary. Now you're going to do the right thing, say -2 here, it's not exactly sharp. Okay, and then we're going to say right around here, we can say this is 1, this is 2, this is 1, this is 2. So we're just doing a sketch, okay? Not a big deal. But now we want to make sure the points of intersection are caught. Now, what do we want? The first one is -1 is to -2. So this one is here. That's the first point of intersection. And then the next one is 2 is to 1. So this one is over there, right around there, okay? Of course, it's just a sketch I'm doing here. I'm not going to complicate my life. So I think we need to adjust our -1 because it's going to create a bit of a problem. This one needs to be adjusted just a bit. Just a bit. So what do we want? We want to make sure this falls onto this line. Maybe let's put it right here and say this is -1. Okay, it's not really best, but I just want it to fall onto this line. Now, but I think I messed up, eh? Yeah, man, I messed up a bit. Yes, this is not good like this. Anyhow, so let's put it back and say this is going to be there. It's fine. So I need to adjust this point. Whew, this thing. Okay, guys, sorry for this. It's doing things I did not expect, but I don't want a horrible sketch. You don't need to spend too much time there. Looks like I'm not doing anything different, am I? Yeah. Yes. Okay. So let's put it here and say there is the 1. Okay, we can now somewhat adjust the things. Let's just put it there. So I think it's better there. All right. So we know that the y-intercept of this other graph is -1. So we expect this graph of this other function we expect it to do stuff like this. This is g. Okay, this is g. This is g, isn't it? because G will cut at -1. Don't worry about this being off center. And then at those 2 points, it is equal to the graph of the hyperbola, which we are going to draw next in this color. We know that the hyperbola is doing things like that. Okay? And then it's doing stuff like this. Okay? Don't worry about the shapes not really being that good, but it gives us an idea of what is going on. Then maybe we can extend our axis a bit. Okay, so that is the story. That is the story. So we don't want to complicate anything here. Okay, this is now F. Okay. So easy, né? Very easy. So this is what the graphs would look like. They didn't ask for many things. We know that this one will never have intercepts, but this one has a y-intercept at -1. The x-intercept would be at 1. Spare that my graph. I mean, when you're using a ruler, you're gonna get it right, isn't it? Yeah. When you're using a ruler, you're gonna get it right. So that's it. That's it. That's it. So we're getting 3 marks. Nah. So I think 1 mark is the points of intersection, which of course you can just show that way. Or you can just write them down in coordinate form. And then it is the points of intersection shown both the shape of that graph and the shape of the other graph. That gives us the 3 marks, I would believe. Now it says use your graphs to determine the value or values of x for which f, this one, remember this one is f of x. This one is g of x. Okay? So when is f of x greater than g of x? Meaning we want to know, when do we see the graph of f appearing above the graph of g? Now, we need to be a little bit creative. Now, if you look in this region right here, if you look in this region right here, look at that region. What do you see? The graph of f is above the graph of g. Okay? That is true. And then again, where else do we see this? If we see here, in this region, again, if you're looking there, you will notice that in this region, the graph of f is appearing above the graph of g from this point going that way. And then here, it's all in this region, because past this point of intersection, you will see that the graph of f is lower than the graph of g. And this goes on until we reach the origin, where now, past the origin, this one is lower than the graph of f, until we reach that point, and then they switch positions. All right, so we can tell that those are the 2 regions that we need to describe for this situation. So 4.3, we can tell here that, well, f of x, we're just interpreting it, is greater than g of x such that x, what should x be? Well, we know that x must be less than 2, right? But greater than 0. That's number 1. Comma, also, we know that x must be less than -1, isn't it? Because if we go all the way from -1 to infinity, this would be satisfactory. So normally you get 2 marks for that, and then an extra mark for that. How many marks? 3. Yes, it makes sense. So this is how you answer this question. So the last question here says, if h of x is 2 divided by x plus 3. So what happened here? We added a 3 to our original f graph in the denominator right there. So we added a 3. And what else did we do? We literally subtracted a 4. So do you see from this graph, we are shifting this graph about. Okay, whenever we add to x, that's a horizontal left shift or horizontal left translation. Then when we subtract from the y values, this is basically a vertical down shift or a vertical down translation. All right, so that is the information being given. It says now describe the transformation that takes f to h of x. So we know that we're taking the graph of f and shifting it horizontally to the left 3 units and downward 4 units. So that is as easy as that. 5.4. Oh, where did I get 5? 4.4. We can say the graph of f of x is shifted what is this now? Is shifted to the left by 3 units. Okay, maybe shifted to the left, maybe horizontally. It's much more important to specify. Is shifted to the left horizontally. Okay, by 3 units and vertically down by 4 units. Okay, so that is it. 2 marks most likely. Yebo. So the description of the left shift horizontally and the down shift, by those units. And that is the transformation. So this is how you score those marks in this question. Easy and straightforward. Let's move on. Question 5 says, the diagram shows the graph of a parabola f of x, which intersects the x-axis at m and 0. So this becomes an x-intercept, and that is also an x-intercept. Okay, now the next one says, it is further given that 1 over 4 is to n is the turning point, okay, of the parabola, while 0 and 6 and also k and 6 are points on the curve. Now remember, this is its y-intercept, but we know that symmetry in a parabola will tell us that the distance, if the y-intercept, or should we say the y value of those 2 points, this point here is a reflection of that. Alright, so we can use symmetry to find k, because we know if from 0 don't know what is happening there. If from 0 to this point right here, it's a quarter unit, that means we're going to move another quarter units to get to this point. All right, so it means we're going to move a quarter unit also to get there. So which means this is going to be a half, because 2 quarters give us a half. So that would be a half. So k is a half, basically. So we're just interpreting the diagram, so to speak. And then again, we will check and say from a quarter to 2, what happened? To move from there to there, such that we are landing at 2. How many units is that? Okay, so let's see. 2 minus a quarter will give us that distance. 2 minus a quarter is basically 7. So this distance is basically 7 over 4. I don't know why I can go. So this is 7 over 4, okay? Units, meaning from this axis of symmetry to that point, 2 is to 0. It is 7 over 4 units. Now, when we want to go back, we basically are going to take that quarter and subtract 7 over 4, okay? So we're going to say a quarter minus that same distance that we want, so that it can give us the value. So it tells us that now m over there must be 3 over 2, but minus 3 over 2, because this distance should be the same as this distance going to that point. Okay, so these distances should be equal because of the symmetry, or the axis of symmetry of the parabola. So by using all of that, do you see we've found m, we've found k easily. Anyway, now, yeah, that's it. I think let's just move on. It says now determine the value of k. Again, 1 mark. So once it's a 1 mark, you already know that you're going to be using symmetry there, which is pretty simple. So let's do. So 5.1, we know that k is basically going to be 2 minus the quarter, right? Not a half, but a quarter, sorry. You're subtracting that x value because k is basically the value from halfway there to there. All right, so yeah, no, that's not true. Here you went. Don't do this. We know k is basically 2 times, remember, from 0 to there it's a quarter, then we're going to move another quarter as well. So it's basically 2 quarters. So it's going to be 2 into 1 over 4. The reason is just symmetry of it. So you're using symmetry. So that's why you're not copying, you're not lying, you are being logical. So k is going to be a half. So always try to answer the question. It says determine. It didn't say write down. So you get a mark. But if you don't show us how you got that, maybe you may have a problem. Maybe you may not. But a 1 mark question, usually, if you just show up with the answer, nobody is going to punish you. Now the value of m, again, it's 1 mark. Do you see? So I'm sure if you just show up with the value, no one is going to punish you. So let's do it. 5.2. Now we know we are going to say 5.2 should be a minus 3 over 2. But how do we express that? So this one is a bit tricky because, I mean, if you're looking at the marks, you already know what you did. Sometimes I wouldn't bother myself here. I would just write m is equal to minus 3 over 2. Again, I've just used symmetry. That's what I did. Of course, it's a bit more detailed because I needed to first find the distance between 1 over 4 and 2. I knew that this would be the same as 1 over 4 going to that minus 3 over 2. So if I take this 1 over 4 and subtract this distance, I would get that. But for someone who would rather we show how we work this out, let's just do it properly so that it doesn't become a bit naughty. We know that m is going to be a quarter, right? It's going to be a quarter minus what? Now, the minus part here, we're going to take this quarter and subtract this distance, which this particular distance is the same as this one, which is 2 minus a quarter. Okay, so this one looks a bit complicated, but I'm just trying to show you everything I've done on the graph, but putting it down. So when you sort that out, you will see that you will get the same answer. So this is so good. So this is minus 3 over 2. So sometimes if you show up with the answer, you may be awarded your marks, but I'm just trying to show you the logic behind all of this. Okay, so that's it. Let's move on. You saw how I did everything step by step. Now the value of n, okay, we want the the y coordinate at the turning point, and show all your workings. Now this is already telling you this is not a walk in the park. It's pain. Okay, so how do we plan this? Look, we know the roots of this graph, so we can find the equation, so to speak. But the smart way to do this, let's say 5.3 is answered like this. We know that is it f of x even? Yes. So we know that f of x should be equal to some a value, which is the coefficient of the x squared, into x minus the first root into x minus the second root. Okay, that is what we know. This form can be very useful because it can help us to determine a, because we've got the x-intercepts. So this is the root form. This is basically a. Okay, maybe let's substitute things now. Okay, maybe let's do it like that. A into x minus, the first root is going to be minus 3 over 2. It's going to be plus 3 over 2, right? And then it's going to be x minus, now that one was just a 2, so it's going to be minus 2 like that. Okay, so what do we do now? We know one point, which is the y-intercept. So we can say through that point, so that we can solve our a, we know that through point 0 is to 6, which is the y-intercept. It will be such that 6 is equal to a into, now this is 0 plus 3 over 2 into 0 minus 2. Okay, therefore our a is going to be equal to, now remember you're multiplying these two, so it's going to be basically 3, minus 3, okay, because the 2's will cancel. You get minus 3, and then 6 divided by minus 3, it's a minus 2. But now what do you make what do you make of a being a negative number? It doesn't really matter that the value is a 2, but the fact that the sign is negative, it makes sense because our parabola is a grumpy face. So we know that for a parabola, if we say f of x is equal to ax squared plus bx plus c, if a is less than 0, the parabola always looks grumpy. Okay, so it looks really okay, even if we may be wrong about the value of 2, but the sign is making sense. Most likely we are correct. Okay, now this implies, now I want us to use another form. This implies that f of x, if we use the vertex form, it's going to be a, which is minus 2, into x. Now remember, what is that? If you're looking at the axis of symmetry, the axis of symmetry is a quarter, right? Now we can actually use the vertex form or the turning point form. So always put the sign to be opposite what it is on the graph. You square that. And then we're going to take down q, which is just plus n, because we don't know what that n is. But one thing for sure, n should be positive because n is on the positive y-axis, isn't it? So that value there is a positive value. Whatever size it is, we don't care. It should be positive. Okay. Now, what do? We can still take our lovely y-intercept, but for this sake, we can use our x-intercept. We can use this point just so that we don't look to be, doing the same thing. So let's say now through this point 0 and 2. What is the case? We know that 2 is equal to minus 2 into, this is 0 of a quarter squared plus n. Interessante. Now this tells us that we've got 2 equals, now a quarter squared is 1 over 16, right? So we've got minus 2 into 1 over 16 plus n. Okay, now let's just simplify further because this is the last question. We can indulge if we want. It's not a big deal. Now what do we do here? We're going to have 2 equals, when you multiply there, you're going to get minus 1 over 8 plus n. Therefore, our n is going to be 2 plus 1 over 8. Now, 8 by 2 is 16 plus 1, 17. So this is 17 over 8. Okay. Easy stuff. So that makes a bit of sense because now let's look at this y-intercept. It's a 6. So let's say 17 divided by 8, it's what? No, something is not right. Something is not quite right. What is happening? It doesn't make sense. This value is too small. This can't be a 2. This cannot be a 2. So why is this x-intercept not working? Why? Come on, man. Why aren't you working? It's not really doing the things now. Okay, maybe we used the wrong one. Maybe let's use the same y-intercept because this value here is not correct. We can't get a y-intercept that is lower than, we can't get a turning point that is lower than the y-intercept in that setup. So our choice of substitution is wrong. I will think about it a second and say, why doesn't it work? Because it has to work. It has to work. So let's use that y-intercept. You can use this point as often as you want even. I was just trying to, change gears a bit. So let's go on. This is going to be 6 and see if it will make sense. This is minus 2 into 1 over 16 plus n. Okay. This implies 6 is equal to minus 1 over 8 plus n. Therefore, n is going to be 6 plus 1 over 8. Now, 8 by 6 is 48, isn't it? Yeah? Yeah? No? Yes? No? Yes? No? I think it's 48. Yeah, 8 by 6 is 48. Right? And then we're going to add 1, which is 40. 8 times 6 plus 1, it's 49 over 8. Okay? So this one, let's check. 49 over 8 is what? Yeah, 6,125. So this value is higher than this value right here. So it makes sense. The turning point is always either higher than the y-intercept if a is less than 0, or it will be less than the y-intercept if a is greater than 0. So this one makes sense. So guys, sometimes you need to adjust some of your workings because they can be crazy. But in any case, you could have found the equation, because you see this one kind of gave us a bit of a nightmare. You can actually find the equation of this parabola. Then from the equation, you just sort out the turning point as you normally do. Makes life easy. From that equation, you just substitute x being being a quarter. Then you'll find the corresponding y value. It's going to be this. Easy. So you may not have to interchange between the two forms of the parabola, as I have. So you can just do that for yourself, meaning you can approach it this way. Let's just do it for fun. Sometimes when we're learning, we have to take a bit of time to work things out. Let's say from this step, you went into saying f of x is going to be minus 2 into x minus, it's going to be plus 3 over 2 into x minus 2. Okay, if we solve this equation, we're going to have minus 2 into, we deal with that quadratic, is going to be x squared minus 2x plus 3 over 2. What is that? So minus 2 plus 3 over 2, it's minus a half. Okay, then this is going to be minus, this one is minus 3, right? And then we then solve this thing. Is going to be minus 2x squared plus x plus 6. Makes sense because the y-intercept is coming out as it was, a plus 6. And we also know that the coefficient of the x squared is a negative. And since we saw that the graph is a grumpy face, you do that. And then from this step on, what do? You can just say then f of a quarter, because you just take that value of the turning point. It's x, that is a quarter. It's going to be equal to minus 2 into a quarter squared plus a quarter plus 6. And then let's see what we get. Minus 2 into a quarter. We square it. I went. Second, get a jwalo. Ke tlo hlanya. I ke batle ho hlanya. Ngwaneso. Yes, it's 49 over 8. So perhaps this is much shorter even. So you can say therefore n is that value. In fact, let's do it the right way. I always like to do the things properly. You know how I am. My intention, guys, is to show you principles, because I know sometimes your teachers don't care about, laying down those strong foundations. They just want to take it easy, They want to take it easy. We can say then n is going to be f at a quarter. You do that, this implies that n is equal to, you substitute, and then you get your answer. Okay, great. So I always like to show you guys how to work things in a systematic manner. Maybe, just maybe, you may want to keep it to that, because look here, we sound like crazy people because we're substituting this point twice. But again, it is very fair because we're using two different forms of our quadratic. So this could still be acceptable. As you can see, it gives us the answer, but it may have easily landed us into problems when we substitute the x-intercept rather than the y-intercept, which is a bit technical. So at times you may have to adjust by making sense of the answer, or you try and do it the standard way and life becomes easy. Okay, that was the last question there, guys. 5 marks. It's complicated, but I can tell you this is correct. You get a mark for that. And now, depending on how you did this, if you get to this point, you get a mark, and then you get to this point, you get a mark. This is how many marks now? This is 1, 2, 3. We need 2 marks. Now you can decide that you're marking the correct substitution here to get the 4th mark, and this expression right here is important to get the 5th mark. So this is how you can get the 5 marks if you go this route. But the 5 marks, according to this route, for you to be able to write it in this form, that is more important because we've actually substituted into some sort of a formula. And then again, we can safely say this writing is important, but then substituting this point in here makes it all fun. So we've got how many marks? We've got 1, 2, 3, 4, and then where would be the 5th mark? Yeah, this one becomes a lot sillier, but maybe this writing would be important. Yeah, to write it like that is important, and then we sort it out. Great. Yeah, so this is how you could get those marks easily. Okay, let's move on to the next question. Now here we've got an exponential graph. Now we're told in the diagram f of x equals a to the exponent x. Okay, now b, which is 3, is to 3, and 3 over 8 lies on f. Okay, there's that point right there. Great. Now what do we observe? We can see that this graph doesn't seem to touch. This graph doesn't seem to touch this line, which is the x-axis. So it means this becomes the horizontal asymptote. Okay, so the x-axis forms the horizontal asymptote, or you say asymptote. Let's just put it some way. I don't know, maybe let's put it there so that it doesn't interfere with our work. Okay, so again, what do we notice? The graph appears above the horizontal asymptote. So if it appears above the horizontal asymptote, it means the coefficient of a is greater than 0. I don't know now what are we going to use, because we normally use a as the coefficient of the function. Come on. And then that means the sign before a is basically a positive sign. But now let's look at our graph. Our graph is an increasing function. as we move from left to right, it is increasing. So it is an increasing function, so to speak. So now if it is an increasing function, we know that the base of our exponent, meaning a, should be greater than 1. Ne? For this to be the case, a has to be greater than 1. Okay, easy stuff. So these are some of the things you want to think about, internalize, and work with. Normally, f of x for an exponential function is a times b to the exponent x. Now we know that when a is greater than 0 and b is greater than 1, the graph is an increasing function like that. Okay, so this combination always tells us the shape of the graph, that the graph will appear above the horizontal asymptote, and that b should be definitely greater than 1. So we know that now in this case they replaced b with a and then left this one unknown. Okay, so that's not a big deal. So this is what you need to understand about an exponential graph. So now it says show that a is 3 halves. Okay, we can do that easily. Yeah guys, time and I've lost it more than I actually wanted to. 6.1. Let's see. Okay, we know that f of x is a to the exponent x through point b which was 3 is to 3 and 3 over 8, right? Was that so? Yeah. What do we know? We know that now 3 and 3 over 8 is equal to a cubed. Great. So now that means we have to express this in terms of some base raised to exponent 3, because we want to eliminate that 3, is it not? Definitely. So how do we do this? 8 by 3 is 24. 24 plus 3 is 27 over 8. Okay, is equal to a to the exponent 3, or a cubed. Now, can we express this fraction as a base raised to exponent 3? And the answer is most definitely. 27 is 3 cubed over 8 is 2 cubed, and then we can just put the cube outside. So this is now a cubed. Therefore, a is, now if you've got powers that have different bases but the same exponent, it means you can drop the exponents and take the bases. So a becomes a 3 over 2, which is exactly what we're supposed to find. Okay. We've done it. So we're getting only 2 marks. I guess here the most important is the correct substitution and the final answer. Maybe not necessarily the final answer because we've been given. But I think expressing it like that so that it links up with the answer is much more palatable. Now I told you, write down the domain of f. Remember now, when we talk of the domain, we're talking about the x values for which the graph is valid. Now let's just look here. If we move from infinity, we go on to infinity. Okay, so do you see? We still see the graph. The graph is coming all the way from infinity, and we're going to 0. It's still there. We're going past 0 to positive infinity, still there. So if it takes infinity to infinity without any skips and jumps, so we know that, well, the domain here is such that x is an element of real numbers. Okay, that's what you do. And it's always like that. It's an element of real numbers. Nah. Done. So how many marks there? 1 mark, because it indeed deserves a mark. Now it says draw the graph of G, the reflection of F in the line. Now when you say something is a reflection, it is a flip, but this line y equal to x, it's an inverse line. This is an inverse line. So ideally this means we want the inverse of f, basically, showing all the intercepts with the x's and the coordinates of another point on the graph. So honestly, this is going to be easy because we know this graph was not shifted about or anything. So we know the y-intercept here should be 0 and 1, almost always. Because when you put x as 0, any number to exponent 0 is basically 1. So this is basically going to be 0 and 1. And then we want to draw, let's just do this line first. Let's just extend the x's here. Okay, I'm just going to draw it up there because I don't have the time, guys. You guys probably do have time. I don't. Now let's look at this graph. The inverse, according to this line, y equal to x, no, I don't know, how will I move this thing around? Let me try and see if it will work. As much as it's going to move some words around, yeah, it's doing it. Okay, so this is the line y equals x, which is our inverse line. So now when we flip this graph here about this line, it means you're just going to flip it across. It should come out here. It's going to do stuff like this. It's supposed to do stuff like so. Okay, so don't worry about the fact that it's ugly, but it didn't come out the way I wanted. So izamekile ne? Yeah, izamekile. So that is the one. That would be the inverse. And then of course, what was the y-intercept becomes the x-intercept. So this is 1. Okay? Meaning this point is 1 and 0. So whatever was the y-intercept on the original, on the inverse, it becomes the x-intercept. And then we can look at the reflection of that point B. So we can just say B prime. B prime is going to be the reverse. It's going to be 3 and 3 over 8 is to 3. Okay, so that's how it's going to work out, and that would be G. Okay, great. So guys, you need to know these things. I cannot overly emphasize these. So this is 6.3, so just say C graph, because most likely you'll be given a graph paper. If you haven't, you're going to have to work on your answer sheet, but we want and expect to see those things. So you're going to get a mark for the shape, you get a mark for the extra point, you get a mark for the x-intercept, which should be those 3 marks. Okay, easy stuff. Easy, 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 easy. If you don't know these kinds of things, please, there's plenty of videos I have done in the channel. You can look from the trial papers of last year. to even papers before last year that I have done, but I think I've done a lot of work on these. So you should be able to find videos that tell you exactly how inverses work. Yeah, you should be able to see those things nice and easy, and then you come back here and then you'll be able to understand why it is like this. Sometimes you just want to use logic to move quickly, but if you're not convinced, you may want to work it out and say, fine, if my f of x is equal to a 3/2 to the exponent x, right? To get an inverse here of f, it will be such that you put x for where y should be, and then this forces you to introduce logs because you want to make y the subject of the formula. And then we know that the log rules will tell you that you can do this y log 3/2. And then you divide by log 3/2. And then this cancels. And then you end up with y equaling, now if this is the same base 10, this is the same as just log of the number x to the base 3/2. And this is the graph of g. This is the graph that we ended up drawing over there. So, should be easy, eh? Should be easy. It should be very easy. Okay, guys, not a big deal. So I'm just showing you some of the things you may need to do if you are lost, you're not sure what to do. You first start here. Then you know that when you're drawing a log graph has a vertical asymptote instead of a horizontal asymptote. It's always the case. So it will have a graph that is a vertical asymptote if you have not reflected it. But if you start doing reflections of this graph, then you may start to have different asymptotes because they will also reflect about. Okay, guys, we've spent too much time here. Let's go. Write down the equation of g. See, write down. So now, having done what we just did, so 6.4, we know that g of x is going to be log of the number x to base 3/2. They said write down, but if you wanted to know how to determine it, this is how you go about doing it. Next, write down the values of x for which g of x is less than 3. Okay, now look at that. If you focus on this portion of our graph, okay, and you focus, but of course this is not quite correct, eh? Yeah, I don't know why I didn't do it so well. Anyway, it always happens, is it not? It always happens. So sometimes when you're dealing with sketches, yeah, it can be a bit of a problem. Can be a bit of a problem. I'm trying to think. What must be the story now. Yeah, but in any case, guys, this graph decreases here. You know, in this region it decreases all the way to a value less than 3, because we can tell that this point is elevated up to 3. Just don't worry about the fact that the scale is messing up everything now. It's because of our sketch. If you drew it yourself, it would be better than this. Anyway, so we can see that the region is that x must be less than this 3 and 3/8, but greater than 0. That's it. So so we know that, well, to answer 6.5, x must be less than 3 and 3 over 8, but greater than 0. Okay, because that is the stretch in which x is basically less than 3. Nice. I mean, that graph of g is less than 3. Okay, so that's it. So they're just giving you 1 mark. Normally you get 2 marks for that. At this point, probably be told time is up. So icon, there's so much. Look at that. So many questions. Why did I take I did it so slowly. Yeah, that was crazy, ne? Okay, just a moment. Okay guys, let's just go on. Let's see if we cannot take it down by the next hour. So trigonometry, given cos 40 degrees equals t, without using a calculator, determine each of the following in terms of t. First of all, take that statement and work with it. Okay, this question is famous. Sorry, it's common. It's always easy to deal with it. Okay, spare that in the November exams, they kind of made a meal of asking this question, but it's usually very easy. Okay, yeah, it's slanted. I don't know, man. I can't really see clearly. If everything is going the way it should, doesn't matter anyway. It's not about beauty, it's about principle. We're dealing with principles here. So now when we do cos 40 degrees, we know that the terminal arm is going that way. Maybe let's make it a bit steeper. Okay, so this must do 90 degrees. Okay, this must do 90 degrees, and then we've got 40 degrees. If this is 40, then this should be 50 degrees, right? So always work out all possible angles in trigonometry. It makes life easy. And then now, how do we define cos? Cos is adjacent over hypotenuse, so it means we've got t here. Okay, this distance from the origin to that point, it's t units, and then hypotenuse is 1, because cos is going to be t over 1. That's why we end up with a t. So you always write it in a way that is user friendly, so that you can be able to draw the Cartesian plane sketch. And there it is. So this means this is a standard circle with a radius of 1, because r simply becomes the radius. Okay, now that we have this, by Pythagoras, you know that x squared plus y squared is equal to r squared. Now x is t squared plus y squared, which is what you want, is going to be that. Therefore, you know that when you work out here, we know that y is going to be basically the square root of 1 minus t squared. Then of course we get this one from Pythagoras. So this is stuff you do before you are even asked a question. So you know that this is going to be 1 minus t squared. Okay, easy. Now once you've done that, you've done most of the work, because to answer these questions becomes easy. So we're doing 7.1. 7.1.1. It says now 1040. 10 is defined as opposite over adjacent. So this is going to be the square root of 1 minus t squared all over t. And there's nothing you can do here. So you look at those marks, 2 marks. So this is a mark for the numerator and the mark for the entire thing. Okay, because you had to work it out. So you're getting a mark for doing that calculation. Sometimes you may not even need to show the calculation. You just show that value. It's much easier. 7.1.2 cos squared of 130 degrees. Okay, now how is 130? So always investigate. If you're given an angle that is strange, ask yourself, how is this angle related to the angles I'm given? For example, I only have 40 and 50 and 90. I do not have 130. So how can I get 130? This is easy when you use reduction formula. Say, okay, fine, 130 is the same as 180 minus 50 degrees, right? Because definitely 180 minus 50 is 130. But now this is squared. Easy. Now using reduction formula, we know that this is the same as, now 180 minus 50, this is the second quadrant. Cos is negative, so this is the minus cos of 50 degrees. But because this is squared, so you square it. Easy now. Easy. What is cos of 50? Now cos of 50, the adjacent side to 50 is now that side. And then of course the hypotenuse side to 50 is still the same hypotenuse that we had before. So cos of 50 basically is minus the square root of 1 minus t squared over 1. But now we're squaring it. So when you square this thing, it becomes just 1 minus t squared. Easy answer, ne? Yes, easy answer. So these questions may look difficult, but they are not. So what is important here? Well, I can give you a mark there, substitution, and then the answer. Everything else is what you should know. 7.1.3. We're saying now cos of 220. Now, how is 220 related to the angles that we've got? Now, we look at it and say, okay, 220 is, in any case, in the third quadrant. So, is it 180 plus? So, let's just say 220. You just take that 220 and minus 180. It gives us 40. So basically this is the same as cos of 180 degrees minus 40 degrees. So you see, this is how it's related to these angles, because we only have 40 and 50. So always try those. And then this is the same as minus cos of 40 degrees, because cos in the third quadrant is negative. Sorry, this is plus instead of minus. Sorry. Okay. So that is the story. So this is the same as minus into what is cos of 40. We're given that it is t, which is just minus t. So again, not a very direct question, but easy. So what matters is to be able to do that. You substitute and you write your final answer. Sometimes I think it's safer to express it like that or whatever. I mean, it's not a big deal. So this is how you sort out these terminal diagram type of questions in trigonometry, and they are the easiest. So please know that here you are going to always be able to need reduction formulae. In fact, let me just tell you, BODMAS is the tool to solve these problems. So to solve these problems, you need brackets off, which is basically proper brackets in general or in algebra. Plus, we use these brackets for reduction formulae. And then DMs talks about factors or factorization and wada. Then this one talks about like terms, be it an addition or subtraction. Okay, and then of course we can talk of special angles as well. So this is how you work this out. So if you don't know what this BODMAS is, go and have a look at some of my previous videos where I explained how I use this thing. So again, you are going to be forced sometimes to use factorization. Okay, and then of course factorization, you need to know how to do factorizations of algebraic expressions, be it factorizing a trinomial, factorizing a quartic function, quintic function, parabola. You talk about all forms of factorizations, taking out the highest common factor, or essentially just doing what we call the difference of two squares. And then the last thing that you may need here is identities. Okay, they always get used. Okay, so basically in trigonometry, if you use this 3, this is your most probable one. It works most of the time. This is your second step, this is your third step. So most of the time you will just need those 3 for trigonometry, and you will just sail through whatever section it is. Okay, let's go on. 7.2. What are we given? Cos of 230, sine of 237. Okay, times cos of 147 minus this fraction over here. This is now cos 213 degrees times cos 303 divide by 10, 237 degrees. Now what do we do here? Now we have a problem, okay? Because here you need to use the reduction formula style, but in a smart way, okay? Now let's see, how are these things? For example, if we explore here, what is 237? This is an angle in the third quadrant. This is the same as 180 plus something. So we're just going to take 237 minus 180. It gives us 57. So this is the same as 180 degrees plus 57 degrees. Okay, just write it like that and leave it. What is this one? 147 is in the second quadrant. So you can just simply say 180 minus 147. It gives us 33. So this one is the same as 180 degrees minus 33. So always try to take it down to an acute angle of some kind. Okay, 213, how is it related to this? Again, it's an angle in the third quadrant. So let's see. This is the same as 213 minus 180, which is 33. So this is the same as 180 degrees plus 33. Okay, so let's see, what is this one? 303. This is now an angle in the fourth quadrant. So 303 minus 360, it's 57. So this is the same as 360 degrees minus 57 degrees. Okay, so do you see the pattern? The acute angle is either 57 or 33. This one is 237, is the same as saying 180 degrees plus 57 degrees. Okay, so we can see, okay, all right, okay. So we can actually express these things as these acute angles of 57 and 33. So we start and say, Of course, you always want to write this one nicely. So this is the same as sine of 180 degrees plus 57 degrees times cos of 180 degrees minus 33 degrees, right? Right. Then we say minus, let's sort this out. This is the same as cos of 180 degrees plus 33, was it? Yes. Times cos of 360 degrees minus 57 degrees. All right. All over 10 of 180 degrees plus 57 degrees. So this is as good as that. You always want to show this before you reduce, because it has to make sense to somebody. And then we say 180 plus is in the third quadrant, so this is the same as minus sine 57 degrees. Now cos of 180 minus, so this is into, now this is the second quadrant, cos is negative. Okay, then we take this sine out, and then we deal with this cos of 180 plus, this is the same as minus cos 33 degrees times, now cos 360 minus 57 is positive in the fourth quadrant, so this is cos 57 degrees all over. And then now we've got here 10. Now remember, 180 plus 57 is in the third quadrant. 10 is positive there, so this is the same as 10 of 57 degrees. Okay, looks like we're getting somewhere. Now let's deal with this thing. Negative times a negative is a positive, so we've got sine 57 degrees cos 33 degrees minus, now remember when you put this one inside it becomes a plus. Okay, then we've got here cos 33 degrees cos 57 degrees over, now 10 can be expressed as sine of 57 degrees divided by cos of 57 degrees. Okay, 10 identity. And obviously now when we multiply things out here, now I ran out of space. Why did I run out of space now? What are we going to do, boys and girls? I'm tired of this thing now. Why is it dragging even? Anyway, so from what you can tell here, let's just move this one down for a bit. We'll see what to do about it. Let's just move it down. We need some working space. So this is the same as, okay, maybe let's drag this one. Say this is sine 57 cos 33 degrees plus. Now when we deal with this, it flips around such that we've got cos 33 degrees times cos squared 57 degrees over sine 57 degrees. Now this thing is doing its own things, which is equal to, so we multiply by the common denominator. The common denominator, remember this thing is a whole term. It's over 1. So basically the common denominator here is going to be sine 57 degrees. So if you multiply throughout by that, so when we multiply throughout by the common denominator, which is that, so we're going to get here sine squared 57 degrees times cos 33 degrees plus here is going to be cos 33 degrees times cos squared 57 degrees. Okay, which is equal to, now you can tell here that sine squared anything plus cos squared anything, if the angle is the same and you have those squares, that is equal to 1 from square identities, but it's not pure. We need to distill out something that is not right. So we know that if we take the highest common factor, the highest common factor here is going to be cos 33 into sine squared 57 degrees plus cos squared 57 degrees. This is the same as 1, so the answer is cos 33 degrees. What was the question here? Simplify without using a calculator the following expression. Okay, so we're getting only cos 33, and there's nothing we can do here. This is the most simple. So sometimes they can give you a hint and say simplify to the single trigonometric ratio, but that's what it is. So let's see, what is cos 33? Sorry, it is basically 0,8386705,679. Now let's see when we use a calculator from the top. What is the story here? Sine 237, just to double check if this thing is correct. Multiplied by cos 147. Okay, this one is that minus, now we've got something to deal with here. We've got here cos 213 times cos 303 no man, it's not right, it's not right. So let's start again. Sine 237 into cos 147, okay, minus, now we've got cos 213 times cos 303, okay, divide by tan 237. Yo, I'm getting 1. Where is the problem? I'm getting 1. So where is the issue? There must be an issue somewhere. Where did we go wrong? Oh, yes. The problem is here. Okay, let's fix it. The problem is right over here. Remember, when you're dealing with these kinds of problems where you don't just multiply by an LCD, but you take it out, okay? Yeah, you take it out. So what this means is when we take out the common denominator, this is going to be over sine 57, okay, degrees. So that's when the problem was. And then when we remember, this divide by that is this, and then we multiply by that one there, we get sine squared 57 cos 33, ne? Plus, then here we just get cos 33 times cos squared 57 degrees. Okay, so let's see what happens here now. We take out the common factor, which is cos 33 degrees into sine squared, into sine squared 57 degrees plus cos squared 57 degrees all over sine 57 degrees. Okay, easy stuff. So now this is basically cos 33 over sine 57 degrees. So these are co-ratios, right? Okay, I don't have more space to use now. Yeah, this thing is a horrible thing, eh? Now cos 33 is the same as sine of 57 degrees, ne? Yeah, is as good as that over sine 57 degrees, which is 1. Makes sense, ne? These are co-functions. If you don't believe me, say cos 33 is the same as cos of 90 degrees minus 57 degrees. Is it not? Now when you take a co-ratio, there it's sine 57 degrees, which is why it's like that. Just in case you're wondering what is going on in there. Yeah, so that makes sense because I've already checked. So you can see here a lot of problems. So you needed to first establish what acute angles are common here, and you can use them to get to the answer. But the answer can be a bit nasty, as you can see. And 7 marks are already telling you it's going to be a serious walk in the jungle where there's lots of danger. And you saw we ran into some danger. Anyway, it's good. So let's go on, guys, and finish. Question 8. Prove that tan of x is equal to 1 minus cos 2x minus sine x, all divided by sine 2x minus cos x. So let's sort out 8.1. So we're starting with the right hand side because it's more complicated. So we've got 1 minus cos 2x minus sine x, all of that divided by sine 2x minus cos x. Alright, what is this equal to? Now we look, can we do anything about this? Not yet, because they look a bit complicated. We've got a double angle here, and there's terms everywhere. So at this point, we are unable to do anything as yet. Okay, so what do? Now we follow that first step of BODMAS. Okay, brackets off or reduction formulae, division and multiplication, like terms, addition and subtraction, or we're taking some special angles which are not here, so we're not going to worry about it. And then we can talk about factorization. Okay, I'll just say factoring. 3, we need identities. Okay, so this is your toolbox on solving this problem. So all we can see here, we don't have like terms, we don't have any factors that we can cancel, there are no brackets to deal with, there's no special angles. So if we're looking at step 2, we cannot factorize this thing because there are no common factors at all between the numerator and the denominator as yet. Now the only thing we can identify, there's double angle identities there, so we're going to strictly run to step 3. So this is 1 minus cos 2x. Well, cos 2x is the same as cos squared x minus sine squared x, okay? Minus sine x. Okay, great. So we used an identity for the cos 2x. Then let's look in the denominator. In the denominator, we've got sine 2x. So that's again an identity of a double angle for sine. So this is the same as 2 sine x cos x minus cos x. Great. Now we can see, okay, there's the sun coming in the horizon. What is going on in there? We can simplify the numerator first because it needs to be simplified. So this is 1 minus cos squared x plus sine squared x minus sine x over, this is now 2 sine x cos x minus cos x. Okay, so what do we do here? Now we can be smart about our business and say, all right, okay, all right. Now we've got things that we can do. We can group terms here. We can see here we've got sine x. Actually, 1 from square identities. 1 from square identities can be represented as cos squared x plus sine squared x, and then minus cos squared x plus sine squared x minus sine x. Okay, at times it depends on the approach you chose. It can be a nightmare. Then let's continue here. We've got 2 sine x cos x minus cos x. Now we can see here we've got like terms, they cancel out. We've got like terms, they add each other up. So we've got 2 sine squared x minus sine x over, now here we've got, I'm dragging this one, 2 sine x cos x minus cos x. Okay, not a problem. Now let's do the final kick. What can we do here? Well, we can't do anything because we can just factorize these things. So we're getting to step 2. Let's factorize. By the way, we've already chosen the like terms on the numerator there and dealt with them. So if we take out the common factor here, the highest common factor at the top is basically sine x. Then it becomes then we're left with 2 sine x minus 1. All right, and in the denominator, the highest common factor is cos x into 2 sine x minus 1. And then these two onto each other. And sine over cos of the same angle is basically tan of x. This was equal to the left-hand side. Okay, so I was just dragging, guys, so that I can show you how to work things out nicely. There's plenty of ways you can handle these, okay? You could have changed this one to the sine identity and say this is same as 1 minus 2 sine squared x, so that you just have sines in the numerator only, instead of going about it this way, where you would have to need to change 1 into something else. So sometimes the approach you chose determines how quick you're going to get to the answer or how slow you're going to get to the answer. But either way, if you exercise a bit of patience, you should be okay. You should be okay. So, I don't know, guys, I'm running out of space all the time. So it looks a bit silly now as to what I'm going to do. But what I can do is to what do we do now for the space? Yes. This thing is tiring, you know. I wanna cry. Man, don't cry. A man that cries is not a man. Doesn't matter what people say. Okay. Okay, guys. This thing is long. Why can't? Mara why bantam? Mara why bantam? Ten wengathi nizodinwa nje mina. Sediziva ndidiniwe kungoku. I have a bit of a problem now, guys. And this problem is serious, you know. I don't have space to deal with the next question, which says, now prove, for which values of x in the interval x is 0 to 270, meaning from the first quadrant to the third quadrant, is the identity not defined? So anything is always undefined if you divide by the denominator that is 0. So this will happen when this is equal to 0. Therefore, this expression becomes undefined. Okay? So the denominator has to be equal to 0 for that to be undefined. I don't know, guys, how I'm going to deal with this situation because I don't have space. So what I can do, I will just rub off this thing here. Unfortunately, I don't like to rub things off, but I need to now. It's taking up more space than I wanted. All right, so you saw you saw how we worked 8.1. So 8.2, we know that, well, this will be undefined when sine 2x minus cos x is equal to 0. And this implies what? Now we can transpose the cos, so it's going to be sine. Actually, let's just factorize it so that we can sort it out. So this is the same as 2 sine 2x minus, you're lying. You lie. So this is 2 sine x cos x minus cos x equal to 0, which implies that we've got cos x into 2 sine x minus 1 equal to 0. So this is like a quadratic that was, done things to. So this also implies that now cos x is equal to 0, or sine x is equal to a half, isn't it? Yeah, that is the story. And then of course the general solutions here, because remember, we want the values of x. It's a long one, it's not an easy one. So we know that this also implies that x is equal to, remember, cos is going to be plus or minus. Cos of 0 is basically cos of, arc cos of 0 is 0, ne? Yeah. Arc cos of naught is naught. Oh, is 90. Almost lied to you guys. So this is 90 degrees plus k times 360 degrees, or x is going to be equal to, remember, arc sine of a half is basically 30 degrees, right? Arc sine a half is 30 degrees. So this is going to be 30 degrees plus k times 360 degrees, or x is going to be equal to, now you're going to say 180 minus 30, which is going to be 150 degrees, plus k times 360 degrees, where k is an element of integers. Okay, yeah, that is a bit of a nightmarish one, but again, I've shown you guys how to do general solutions, so that should not be a problem. So once we have those general solutions, we can make a conclusion and say, therefore, x is an element of. Now let's find out. We're going to start from the smallest to the biggest. Okay, so we want it from 0 to 270, meaning only the positive angles, no negative angles. So we can see that when k is 0, in this case here, we're going to have 30 degrees, we're going to have 90 degrees, we're going to have what, 150, and then we're going to have what, yeah, that's it. And then now when k is 1, what happens? Remember, this is a plus or minus. When k is 1, we're going to have 360 minus 90 there, which is going to give us 270. Okay, so that's fine, we're getting 270. So we have 270 here as well. And then the others don't work out. Yeah, they don't work out. Let's see, 360 minus 360 plus 150 is not going to work. It's going to give us a negative angle. It's going to give us a minus 210. I'm trying to figure out now, is it fair to do that? No, we don't want negative angles here. But that 210 is in the third quadrant, so how would we make up for that? I don't know. But it looks like 210 is part and parcel of this thing. How many marks are these things anyway? But 210 does work, but it's a negative angle, but it doesn't matter anyway. Minus 210, what is the equivalent of that angle? Because it's negative, Are they related to 150? But I think 150 already solved the problem, if I'm not mistaken. But anyway, guys, I think this is the solutions. Let's just leave it. So meaning here, k must be 0, because if it takes any other value, it becomes a situation that we don't like. Okay? So I think these are the solutions for this one. First of all, to say this is important, okay? And then these two guys are important. 3 marks. 4, 5, 6, 7. Yeah, looks okay to me. Let's move on. Okay, we have lost a lot of time. Okay, guys, so let's continue. Question 9 says, in the diagram below, the graphs of f of x equals equals sine ax. So if you're looking at the coefficient of that ratio, it is basically 1. And this tells us that the maximum and minimum for this function should be 1 and minus 1. Now let's look at the sine graph. You can see this one is the sine graph. Okay, that's the sine graph. So we can see the maximum is at 1 and the minimum is at minus 1. Okay, so do you see? Everything is representative. But now we have a coefficient of the angle, meaning the period is going to be different. Okay, so let's see. Normally a sine graph completes its cycle at 360 degrees. But now let's look at this sine graph. If you're looking at this segment of the sine graph, if you look here, okay, I tried. So look at this segment. That's a full sine wave because you see it completed from 0 to 180. So it is half of the usual. So now meaning the period of the sine graph is 180 degrees. So it completes a full wave at 180 degrees from 0. So what does that mean? This then means that if we're looking for A is going to be the old period, which is 360 degrees, divide by the new period, which is 180 degrees. This gives us just 2. Okay, so we know that, okay, our A is basically a 2. There are other means to solve this problem. You may not need to look at the period. You just look at a few things that, you know for a fact that a sine graph should be 0 at, for example, 180. But now it is 0 at 90 in this case. So you'd be asking yourself, what can I do here? Easy. I will say the old instance divide by the new instance, which is 180 divided by 90. That still gives us a 2. So there's plenty of ways you can look at that ratio there to determine the coefficient of the angle when it exists. Okay, not a problem. That we can solve easily. Then that's it for the sine graph. We're not going to go further. Let's look at the cosine graph. Cosine graph is basically cos of A plus B. Again, we have an unknown B. But we know that once we have either a sign between the two that represent an angle, this has been shifted horizontally. Now, it will depend on the sign of B to decide whether this is a left shift versus the right shift. But let's look at the graph of cos and explore what is going on. Normally, a cosine graph, because this is what would be the cosine graph, okay, that's the cosine graph. Now, I'm just going to color that segment that we're dealing with. Now remember, cosine graph, normally we're being told the coordinates of this high point right here. So we're being told that the coordinates there is 45 and 1. So do you see, normally a cosine graph starts off by having cos of 0 being 1. But now this one has moved to the right. How many units? It has moved 45 degree units to the right, okay? Or not just how many units, but not degree units, but Oh my lord, I'm mincing my words now. Here's the thing. How many units did we move this point from being at the origin, meaning 0 and 1? We moved it to the right 45 degrees. So that is what happened. So if we moved to the right 45 degrees, what does this mean? It means our function is therefore given by g of x is equal to cos of x minus 45 degrees. That's the case. So meaning b is negative. So if b is negative, then that plus will change to a minus. So these are some of the things, guys, you need to, quickly look at and be sure. And like I said, there are many ways of looking at these kinds of things so that you can get an understanding of what is going on. For example, you may think about the fact that, look, this cos graph, it normally cuts at 90 degrees, right? Because cos of 90 is 0. But now this one is cutting at somewhere between 150 and 120, okay? So what is that? But since we don't know what is that scale, we can't use that point because it doesn't really help us at all at this point. So you just keep looking for a point that you can identify that's easy to use, okay? So I'm not too sure what we can use. If we use 180, we know that cos of 180 is basically minus 1. Is it minus 1? No, it's 0 again. Let me see. Cos of 180, yeah, it's minus 1. Yeah, it's minus 1. So at 180, this is not yet at minus 1. This looks like, yeah, somewhere on the way towards minus 1. So it doesn't really work, is it? Yeah, I think here we're limited to just this portion here. Because as I'm trying to look at other points that we can use, we really don't have values, so we cannot safely, say this is what is going on. Okay, let's leave it at that for now, because we are able to do our magics. All right, so that is it, guys. So sometimes you are limited in terms of options, sometimes you are not. Okay, let's go on. Let's answer some questions. I think we have done what we need to do. It says now determine the values of A and B. 2 marks. So do you see we've already done? Here you may show up with an answer and say A is equal to, B is equal to. It really doesn't matter. Okay. So you don't really have to show a calculation in this type of questions. That means you need to be comfortable sometimes to cutting the corners a bit. So we know that A is a 2 and B is a minus 45. Okay, that's it. Because just getting a mark for each. Yes, the question says determine. You may find yourself thinking, okay, do I have to explain? Yes, you can, but for 2 marks and on graphs, you don't really need to do too much. So just be familiar with how to answer graph-related questions. You don't have to sing a lot. But if you want, you may look into saying, fine, I got this 2 because I know A is the ratio of the old period. You can just say TO, which is the old, over the new period, which is Tn. This is going to be 360 degrees over 180 degrees according to the graph. And that explains why you have that. So you can write it like that. But how will you explain this one? It becomes a bit nasty, isn't it? So you don't want to overly do things. But at times you can, because why not? Why not? Sometimes I do think about things, in a way so that you can be helped to find solutions. So let's see, how would you do this one? This one, you can just take that point A. We can just say A is 1 equals cos of x now is 45 degrees plus b. Okay, that's what we've got. And then now arc cos of 1 is what? Is 0, ne? Yes. Arc cos of 1 is 0. Arc cos of 1 is 0. So this simply means 45 degrees plus b is the same as arc cos of 1. That means 45 degrees plus b is equal to 0. Right? Right. And then we go on, we transpose. B is going to be equal to minus 45. Okay? So this is how you can do this business right here. So, you can show the calculations. It is not really impressive. For just 1 mark, you don't really need to be working out things. If you can figure them out, it's as simple as that. Because you can either use a calculation or use symmetry to just figure things out. Okay? Great stuff. So this is just in case you are wondering, how can you put it in an algebraic way so that you convince someone that you're doing the right thing. All right, not a big deal. So let's move on. Next question. It says write down the period of G. Do you see? We've already determined it. The period of G is this. Oh, sorry, we did not. The period of G is the cosine graph. But now, if you're looking at this coefficient of the angle, it is simply 1. There's nothing else. So when the coefficient of x is 1, the period is 360 as usual. So we can say to answer 9.2, we know that the period of G is equal to 360 degrees. They said write down. So this one is as easy as that. Nothing major. Let's move on. We're told here C is the turning point of G. Determine the coordinates of C. Now, we know that here the value of y is -1. But then we don't know the x value. So it says determine the coordinates of C. So this one is easy. Again, you can just use an algebraic calculation, or you can use symmetry, because if you look, for example, symmetry says if I moved to the turning point from the origin 45 units, right, what must I do here to make up for that? So it means, yeah, this is going to be 45 over here. This is 120. Let me just think. From the nearest, from 60 to that 45, what did we take down? 60 minus 45. We took down 15. So if I look here, I'll say 120. So it's going to be minus 120 plus 15 degrees. So this is 105. So this one should be 105. Again, you can just show up with the answer here. No one is going to hurt you. So 9.3, you can simply say that C is the point 105. 105 degrees is 2 minus 1. That's how you can do it. You can just write it like that. You're getting 2 marks for each one of those coordinate pairs. But if you want to think about it the other way around, you can just say C is such that G, is it G? Yes, is such that G of x is equal to minus 1, because we can tell this is at minus 1. Now let's think about g. G was given to us as what? As cos of x. Now we determined b is minus 45 degrees is equal to minus 1. Therefore, we can say this implies that x minus 45 degrees is equal to arc cos of minus 1. Okay. Now we know that arc cos of minus 1 is basically 180. Ne? Arc cos minus 1 is 180 degrees. So this implies that x minus 45 degrees is equal to 180 degrees plus what did I do here? This is a big mistake, you know. It's not a good thing. That one was a mistake on its own. It can't be 105, is it? Because this is before 120. So before 120 is more than that. So what did I do? Okay, I'm going to say minus 120 minus, minus 120 minus 40, minus 15. It becomes minus 135 actually. So this becomes minus 135. So I made a mistake there in my quick determination. So sometimes when you explore two options, you start to figure it out much easily. Now let's go on, guys. We have work to do. We've got work to do. So now this question here is going to become a bit hurtful, is it not? It's going to hurt. It is going to hurt because I am seeing a problem now. I am seeing a problem because this calculation is going to hurt. Look at it. It implies that our x is going to be equal to 180 degrees plus 45 degrees. So that's another thing now. So 180 plus 45 is 225. But we can tell that no, this is not 225 because this is now a situation that is in the third quadrant. Okay, it's still in the third quadrant if you think about it. But now the third quadrant in terms of some sort of negative angle. 225 is the same as minus 135, right? Right, because what do you do from that 225? You just take out 360. And then it gives us our minus 35. So sometimes you may get an answer like this that can scare you a bit. But remember, to get a negative angle, you just take this value here. And then you just say 225 degrees minus 360. And then it gives us minus 135 degrees. So you always try to find an answer that makes sense. Sometimes a certain calculation will scare you if you're not comfortable doing your business. So at times it's nice and safer to just use symmetry and say, fine, to get to 45 from 60, for example, you see I used this distance here. I just said 60 and identified an identifiable special angle. To get to 45, I subtracted 15 degrees. Ne? And then I'm going to do the same and say, fine, 60 is equivalent to 120. So if I say from 120 to this point right here, okay, so I'm going to ask myself the same question and say, okay, all right, so this must be a dotted line. So I ask myself from 120 to that value, what should it be? I'm going to subtract the same amount that I did from here by just using symmetry. So it's going to be minus 120 minus 15. It gives us minus 135. So you've got two options, guys. You either just write it down like I have here, or you calculate it. But when you calculate it, it can make a bit of a meal for you. It can make the situation a little bit difficult to figure out, but always use equivalent, values. If you get a positive answer, what is the equivalent of that in terms of the negative angles? Always when you do negative angles, you subtract 360 from whatever positive value you got. You will always get the value just right. Okay, so the key here is to always remember, if you get a positive answer but you can see that it's not like that, you always take away 360 to form negative angles. Anyway guys, that's it. I didn't want to say too much. Determine the coordinates of D and E. Okay, so where is D? D is the x-intercept, is the y-intercept of that function. And then E basically is at 180. If you think about it, the x-coordinate is 180, we just need the y-coordinate. So this is easy, not a big deal. So 9.4, we can just say we're starting with D. What about D? D, we know that x is 0 from the function of G. So we just want the we want the y value there. So basically here, we know that x is equal to 0 degrees. This implies that now g of 0 is equal to cos of 0 degrees minus 45 degrees. Let's sort it out. So now what is cos of minus 45? It's root 2 over 2. Okay, that's it. You can leave it as that. So you can say therefore D is 0 degrees is to root 2 over 2. This is a rationalized denominator. It's basically 1 over root 2. Anyway, that's fine. Not a big deal. We are sorted. So do you see, you can do some nice calculations for others, but others can really horrify you. So we can say also C is such that we can choose one of the two functions, because actually not, we still use G, but we know that x is 180. At C, we know that x is 180 degrees, which implies now that G of 180 degrees is going to be cos of 180 degrees minus 45 degrees. What is that? Cos 180 minus 45. It's minus root 2 over 2. Okay, so again, you could have seen that that point is sort of symmetrical with that one, but it wouldn't be too easy when this one is flying and that one is cutting. So at times it becomes a bit overwhelming. So, but if the answer makes sense, you just go on and just write things down. So this is 180 degrees. And then we've got here minus root 2 over 2. And that's it. Okay, so easy guys, not a big deal. Sometimes you've got to do some calculations, unfortunately, to get the marks, but the main thing here is to get a mark for each combination. Next question. Use the graphs to determine the values of x in the interval 0 to minus 180. So we are actually looking at this segment here. Now, when we're looking in that interval, what are we supposed to find? Okay, for which g of x is greater than f of x. Okay, So we want the graph of G to be above the graph of F. So where does it happen? The graph of G, as you can see, this is G, right? And then this is F, right? Right. And then we can almost tell that, look, the graph of F here, we can see that the graph of F from 0 is already above the graph of G until this point where they are equal. Okay? And then as we move down, the graph of G is below, the graph of F again is below the graph of G until this point right here. And they have given us the coordinates of that point, so to make our lives a little bit simpler, because we would have to use general solutions to get this value right here. Then that would be a long question. So to keep it simple, they gave us the coordinates. Makes life a lot easier. So what we can say is, we can just use this interval with some constraints, because we can see that except for this point where x is 45, okay, where x is 45 degrees, except for that, the graph of G is above the graph of F all the way until that point of intersection. So to answer this question, this is 9.5. We can see that x must be less than, okay? Remember, then we don't want them to be equal, so it's only greater. So it has to be greater. So no equality, sorry. Now what do we say here? We simply are going to say, this is now, that point where they are equal again is 165 degrees. So we're going to say here 165 degrees must be greater than 0 degrees, right? Right. But there's a condition that x should not be equal to 45 degrees, because at 45 they are equal. Nice. So you get 2 marks for that form and 1 mark for this. That makes life a lot easier. Okay guys, so please, trig graphs are very nice. These are not the questions to lose marks. They are easy. They are very nice, but you need to understand how to work them. So it's fine. We're going to continue working together throughout the year. I do believe at some point I may do some videos that strictly deal with some trig graphs, be it to draw a graph and work it, or to take a graph that's given and work it, because these are some of the areas that are easy, but sometimes a lot of students make a lot of mistakes and get answers wrong. Okay, let's get to the last question, guys. I already took longer than I wanted to. In the diagram below, Q is the foot of a vertical tower, PQ. Okay, there's our vertical tower right here. All right, and then we're told here now while R and S are 2 points in the same horizontal plane. Usually we'll see that by the shading. So once a particular area is shaded, it almost always represents the horizontal plane. Now the angle of elevation of P is measured from R. As you can see, it's x units. Okay, and then x degrees, and then RQS, which is this angle right here, is represented by Y. Okay, not a problem. And then QS is A meters. We can see that QS is this distance over here. So it is A meters. And then what else? Okay, then we are told here the area of triangle QRS. Hey, QRS is AM meters squared. It's not so strong. Okay, so we've been given quite enough information here. So let's just do things. It says prove that PQ is 2A times 10x, okay, divide by A sine y. It's 5 marks, so this is going to be a rough ride, okay. These are some of the curves that you're going to appreciate, eh? As nice as they are, they can give you a situation. Okay, let's go on and explore those curves and touch them a little. Prove that PQ. Okay, now PQ, if you look at this PQ, what we need to do, we have a y there somewhere, okay? That's the most important thing. And then we've got some 10 in there, meaning we had to use tangent, okay? That's another thing that we need to realize, that we've used 10, but sometimes this 10 may be a different story. But you see 10 is 10 of this angle. How is that the case? Yeah, this is something else, is it not? Yeah, this is yeah, this one is a dangerous one, So basically all this is trying to suggest, it is suggesting that we need to find this side first, okay? Because if we're using this angle, using the tangent of this angle, tangent is always opposite over adjacent, so it means we need to find this dude. We need to find this dude. And once we find that dude and deal with that dude, we are sorted. But now the best way to deal with this, we need to use the area rule, okay? We need to use the area rule, okay? So area rule, we know that it is always half sum of the sides. We can say QS and then times QR times sine of y, isn't it? Because it has to be the included angle. So this is what they used. This is what we need to use. And then of course that actual value, because there is an A here, so this A comes from there, isn't it? So that's simple. So we're going to use the area rule to find QR, number one. Then simply we use this triangle for our final answer to get PQ. Okay, let's get into it. We know that area of triangle QRS is equal to A. Basically, that meter squared, you can forget about it. It is just equal to A. Forget the meter squared. It's going to cause problems. Okay. Now let's continue. This implies that now half of Q. Okay, let's write them nice and easy. Half QR times QS times sine, let's write that angle properly, that is RQS is equal to the big A. Just a moment. Okay guys, I'm cooking, so that's why I'm getting a bit, interrupted. This implies we've got half QR is what we want, isn't it? Times QS, it was given as A meters, right? Then times sine of Y, because that angle is Y, equals A. So we want QR, therefore QR is going to be equal to Now we just cross multiply the 2. It's going to be 2a, okay, divide by a sine y, basically. So do you see, we already have the portions of the things. We've got our friend here, and we've got our friend. So do you see, whenever you have a proper plan, you get things right. And then of course here we can write, this is the area rule. Always be in a conversation with the person who's marking your paper, so that they can understand your reasoning. Even if it's not something that the memorandum may show, then they may be able to follow you and perhaps pick up some of the subtleties that are hiding and perhaps need to be paid attention to. Anyway, now that we have QR, we can say then in triangle, now let's look at this triangle. It's going to be PQR. Okay, I always underline my statement. What in that triangle? Remember, this is a right-angled triangle, so we can use trig ratios. We know that tan of angle PRQ, okay, PRQ is going to be equal to PQ, the opposite, over the adjacent, which is now QR. All right, so that's just simple trigonometric ratios. Okay, so what do we know? This implies that tan of y, sorry, not y, but x, is going to be equal to PQ, that's the guy we're looking for, over QR is that guy that we want, so let's just leave it as QR. Then of course this is over 1, we cross multiply. Let's just try and create some working space here. I never really gave myself enough space here. I don't know why. Alright, so it just wants to slant around, stupid thing. It irritates me when it does that. Well, that's much better. So it's still slanted slightly. I don't care anymore. Doch, I have space. Why did I have to struggle then? Leave it. Anyway. So let's move on. This implies that now PQ is going to be QR times tan of x. Now QR, we found that to be 2a over a sine y. Then we're multiplying that by tan of x over 1. Here there's nothing that cancels out. Numerators multiply together and denominators multiply together. So we've got 2a tan x divided by a sine y, because that times 1 is just itself. And that's it. And that's it. So we've proven it, isn't it? Yes, we've done it just right. Okay guys, so this is the thought process that you need to go through to get things right. So let's not even talk about marks anymore. I'm not interested. But don't forget that when you're doing these types of questions, again, you need to remember your BODMAS, okay? This means reduction formulae. Okay? This can be all about cancelling factors. This can be all about like terms, dealing with like terms, and special angles at times, okay? Special angles, or you're dealing with like terms. BODMAS, it's reduction formulae, or just simply brackets off. Okay, you're taking the brackets off, or you can use trigonometric reduction formulae. Then here you're just cancelling factors most likely, or just doing multiplication and division in general. Then you can do addition and subtraction in general, which is like terms, or you can think of that as using special angles. So this is usually 80% of trigonometry, or at least 90%. And then you can use factorization. Okay, factorization, you're going to use it either in the so-called dots, difference of two squares. You can do a polynomial. I'm just going to say polynomial, because you need remainder theorem to do these things. But if it's quadratic, it's much easier. Then 3, you need the highest common factor. You're taking out the highest common factor. So most likely those 3 will get you going. And then the third one, you need trig identities. All right. So don't forget this. Just because you are here, sometimes it's easy, you don't need it. But you can see sometimes certain questions can be as complicated as needing to employ some of those techniques. Okay, guys, let's just do the last part. 102, 10.2, sorry. We are told now, if A is 89 meters, and PQ is 77 meters, X is 46.5, and Y is 115. It says now round off the answer to 2 decimal digits, which is already the general instruction. I don't know why they felt the need to repeat it. It's ridiculous. Sometimes they are ridiculous, are they not? So what are we supposed to do here? Calculate the area, okay, of triangle RQS. RQS. So that's easy. We're not going to worry about a lot of things. So we know that find area of triangle RQS is going to be, we're using the area rule, it's half QR times QS times sine of angle Y. Okay, it's as simple as that. And then let's work it out. This is 1/2 into QR. Problem now with QR is that we have to deal with it in terms of that expression. So it's 2A. What is that? What is that? Now I can see why this is 5 marks. Something needs to be sorted here. Something. Okay, but we're going to be smart about it anyway, because we know that the area there is A, right? We know that this is A. Okay, this implies that A is equal to, what is this going on here? Yeah, it looks crazy, but let's go on. So this is going to be, actually we need a bigger bracket. Let's just take it down. So QR, we found out that it is 2A over A. What are they telling us A is 89 meters times sine of Y. Y is 115 degrees. Okay, so that's fine. I don't know why I wanted a big bracket anyway. It's not necessary. Okay, now that is that. And then QS is A again, which is 89. So this is into 89 times sine of 115 degrees. Okay, so this is sort of doing the things that we must do. Now if you're thinking about what is going on here, the 2 cancels the 2, the 89 cancels the 89, the sine 115 is cancelling the sine 115. So I'm remaining with a is equal to a, which is bad. Okay, this is terrible because it's not answering the question. Whew. Okay. Yeah. Oh, snap. PQ is 77. PQ is 77 meters. So we need to use PQ, I think. Because if we use PQ has that area. So sometimes your planning may not work. So if it doesn't work, you move on, you try another plan, right? So don't think you're always going to have a direct path. Sometimes you have to test paths and use what works. So let's just go back to PQ, because we can see that PQ gives us everything we want. It gives us everything we want. We know that from above, we saw that PQ is equal to, was it what? 2a 10x over a sine y. Okay, this is easy because now we can isolate a. This implies that a is equal to, remember this is over 1, so you will cross multiply first and then divide by 210x, isn't it? So this is basically going to be PQ times a times sine y divided by 210x, okay? Which we can say now, therefore the area of triangle P, what was the triangle there again? RQS, okay. RQS is going to be equal to PQ. They're telling us that it is 77. Okay, times A is 89. All right, times sine of 115 degrees, right? Sine y is 115. All right, that's not a problem. So we're doing fine. Why do I have yeah, it's good. So divide by 2 into 10. 10x is now 46.5. That's 10 10. Okay, it's fine. Sometimes it refuses to do things. So do you see certain questions need you to answer them smartly to avoid problems? Yeah, it happens sometimes. Okay, let's do it, guys. 77 into 89 into sine of 115. Divide by 2 into 10 of 46.5. Don't do it. It's ridiculous. Yeah, well, 77 into, okay, maybe there's something I need here. 77 into 89 into sine of 115. Okay, yeah, this thing is doing stuff to me now that I really don't like. divide by 2 into 10, 46,5. So this thing is doing stuff to me. Now I'm getting here 2,946. I don't know why these numbers always, yeah, whatever. Comma. Now we're told to 2 decimal places. This is basically 98 meters squared, because we're told that the area is in meters squared. Okay, I hope you guys like it. It's nice and it's easy. I think here the trick is basically, I don't know guys why they're giving 5 marks. Really, this is crazy. Like, why are you giving so many marks? It doesn't make sense, because maybe to do this gymnastic it's a mark, okay, and then to do the substitutions perhaps in the numerator and denominator it's a mark, and then maybe the final answer it's a mark. So 1, 2, 3, 4, maybe we can say 2 marks. Sometimes maybe they saw that you may have to do, you know, maybe they saw that you may have to do sorry, a few things, because substitution really for me is just 1 mark entirely. So it doesn't matter, whatever, you are going to get full marks, because they may have thought of a different pathway of answering this question, and perhaps that one involves maybe 2 steps to make up those 5 marks. But here we just did it in 1 single step, because we just eventually smartly thought about it. Okay guys, this is the end of our attempt in reviewing this paper. I'm sorry for how long I took to do it. This was a 2-hour paper. I actually took 3 hours and 37 minutes, which is absolutely ridiculous of me. Anyway, I kind of indulged too much, but I hope you were able to learn throughout all the shenanigans that I got involved in during this question, and sometimes my over relaxation trying to explain a few terms and concepts. Nonetheless, I hope you learned something, and that you're going to like the video enough to share it with your friends. Giving that thumbs up is a bit of a motivation, to keep me going. Otherwise, it feels as if, okay, this is not significant sometimes. Nonetheless, this thing is going to be delivered anyway, whether you like it or not, all right? So, yeah, that's the case. So, go back, guys, take this paper if you wrote it, look at it again. Now, look at it with more details embedded in your head, so that you can see how easy that paper is. The one thing I can tell you is that the paper was longer than necessary, because if I take this long, I didn't really take too long a time to explain much of the things here. So if it takes this long, it already tells you the paper was unnecessarily long. So, but for a student who knows what to do, most of the questions are pretty straightforward, so you didn't need an explanation for anything there. You could easily have finished this paper before the 2 hours, but then you can see there are some questions, like the last one, that need you to think a bit and to plan how you're going to answer. And then some of the hidden longish questions, but they only have 3 marks in some of the earlier questions in this paper. So in a way, it was a paper that was fair to me, and it's very good for students to essentially learn enough to go and crack those finals with a distinction without a shadow of a doubt. Okay guys, enough is enough. Otherwise we will waste too much time here talking gibberish. So just study as hard as you can. Know that for your June exams you need a strong mark, because your portfolio mark needs to be strong for you to get an overall distinction in your finals. You don't want to do so badly in your portfolio and then you get to your finals, you get a distinction, and then it gets, watered down, as Tulu would say. It gets watered down into some 60% or so, something that may not give you enough chances to compete for your chosen career. So do a good job now. Focus. Do as much as you can. Treat it as a final exam. Every exam that you do throughout the year, so that the final becomes an easy one. Okay. Okay guys, I know I talk too much naturally, but I'm gonna try to cut it short today. Goodbye. I'll see you next time.